which are already present and which we know about. Okay, but these functions can also be categorized into either one, many one, or onto into functions. So we have discussed that in the last class. Now, in today's class, we will be going to discuss about how to find whether a given function is one or many one. So there are many ways to find out this. But when we talk about CBSE, only for strictly for CBSE syllabus, then we have this method in which we can identify whether a given function is one or many one. So how to identify whether a given function is one or many one. So one way is what we were doing in the last class, that we can put the values, right? And we can check whether there are two inputs for which there is the same output. So some functions will be easy to read. Like for example, y is equals to x square. This is easy to read, that this given function is many one, right? Because it gives us two answer for the same input. I mean, it gives us same answer for the two inputs. Either we can take -2 plus 2, both gives the answer 4. And if you put plus minus 3, then you get the answer 9, right? So there are two values for which the output is same. So it is easy to read for this function, whether the function is one or many one. But if let's say if I say this, y is equals to 2 to the power x. Now this function is not that easy to read, right? And similarly, we can have different functions. These are, I will say, these are easy expressions, but there are tougher expressions than this. So it is not a feasible method that we should check every time for multiple values and then we will be able to find out. It won't be efficient as well, and sometimes you won't be able to solve the given function. For example, y is equals to log x. Now, if you take this, you put multiple values, you have to check log table for every value, right? So this is not easy, that we put multiple values and then we will be able to find out. And in fact, in some cases, the function will be many one, but you won't see it directly. I mean, you can't check that by putting multiple values. Okay. So there are, as I said, there are multiple methods to find out whether the given function is one or many one. But in our NCERT syllabus, this is given. So let's say we have a function y is equals to fx. Some function is given to us, right? For example, this can be x square or log x or 2 to the power x, sin x, right? And there are other functions also, inverse function, right? So consider some function which is given to us. Then what do? You take two values, and these two values are not, I mean, these are not your numerical value. I mean, these are numerical values, but we don't know them. So we take arbitrarily two constants, x1 and x2, which belongs to the domain of this function. Or rather, we assume that there are two values, x1 and x2, which belongs to the domain of this function. Which belongs to the domain of this function means that they can be given as an input to this function. So we are taking any two values, x1, x2. Now, I mean, these are not values. हम इनको हमेशा x1, x2 की तरह ही लेंगे, right? These are not values. We will always consider x1 and x2. And what we will check is, we will assume that if we put x1 and x2 in the given function, then the two function produce the same output. We will assume this. We don't know this. We have to find this out, whether this is true or not. But we will start with assuming this, that on both of these values, x1 and x2, our function produces the same result, right? And from this expression, fx1 is equals to fx2, we will solve the above expression for this function, whatever the function is given. Solve the above expression. Now, this is an important line, by the way. Solve the above expression and check if there is only one solution, and check if there is only one solution we have to check that after solving the expression, there should be only one answer, or there should be only one solution of this equation. What is that solution? X1 is equals to X2. If you only get one solution, X1 is equals to X2, then you will say the given function is 1, 1. Otherwise, the function is many 1. Now let's check this, how check the procedure, how to do this by some examples first. So the question is, check whether the given functions are 1, 1 or many 1. The question is, check for 1, 1, many 1. Now, whenever a function is defined, it is not defined. I mean, this is they just won't give you one second. Yeah, so they just won't give you the expression. They will also provide the range, I mean, domain and codomain of the given function. So let's say there is a function f. So how will we define the complete function? We will define the domain as well as codomain of the given function. So this is a notation for definition. The first thing here represents your domain, and the second expression here, or second set here, represents your codomain. So Z, that is set of integers. We know that Z represents set of integers. So what it is saying is, first I will complete the whole question. Y is equals to fx is equals to x square. So first you try to understand what is written here. We have been given the domain as well as codomain and the expression of the function. So this is domain. The first set written here is domain. The second set written here is codomain. And this is the standard procedure. And this is your expression. Y is equals to x square or fx is equals to x square. You can write it anyway. So this is how the function will be given. So we know the domain, that we can put any integer in this. We know the codomain, that any integer can be the answer of this. And now we also have the expression. To check for 1, 1 or many 1, what you need to do is, you'll start by taking two values, x1 and x2. So consider, always start your question like this. Consider x1, x2, which belongs to Z, your domain, right? So you have chosen two integers. You don't know the value of integers. You have just chosen the two integers, x1 and x2, right? And you'll start with, you will start with an assumption that fx1 is equals to fx2. Now, first of all, what does that mean? fx1 is equals to fx2. We are saying that on both of these two inputs, x1 and x2, right? The output is same. fx1 and fx2 is same. What does that mean? That your fx was x square. So if you want to find out f2, what would you do? You will replace x with 2, right? So after replacing x with 2, the answer is 4 for x is equals to 2, right? Now, if you want to find out fx1, what will we do? We will replace x with x1. So this should be x1 square. And similarly, fx2 should be x2 square, right? So we are saying that fx1 is equals to fx2, which gives us the expression x1 square is equals to x2 square. Now we can solve this equation. How? X1 square minus x2 square, right? Now we can factorize this. This is x1 minus x2. And this is x1 plus x2. So either this first expression can be 0 or this second expression can be 0. If your first expression is 0, then x1 minus x2 is equals to 0. And if second expression is 0, then x1 plus x2 is equals to 0. The first expression gives us the answer x1 is equals to x2. And the second expression gives us the answer x1 is equals to minus x2. Hanji, so we got two answers here. X1 is equals to x2 and x1 is equals to minus x2, right? So the initial procedure will be same for every question. You will start with taking two values x1, x2. You will start with this assumption fx1 is equals to fx2. Then the question will change from this point. Why? Because the expression for every function will be different. Right now we are checking for x square. This could have been different. This will be different in the next questions. So these two lines will be same for every question. You will start with considering two values from the domain. Then you will assume that fx1 is equals to fx2. And after that, you will take the expression and you will find out the solution of that equation, right? Yeah. So then after this point, you'll start solving the question. You'll find out the value of fx1 from the given expression. You'll find out the value of fx2 and then solve this equation. After solving this equation, you should only have one answer, which is x1 is equals to x2. Right now, we have two answers for this. X1 is equals to x2 and x1 is equals to minus times x2. Now you can also understand it practically what is happening here. In the first case, it is representing that x1 is equals to x2 means if fx1 is equals to fx2, that if the output is same, then input has to be same. First, this solution is representing this thing. The physical interpretation of this is like if the output is same, input has to be same. Now the second solution represents that output can be same if both of the values are same but opposite in sign. For example, 2 and minus 2. If you put x2 2, then x1 is minus 2. While in the first case, first solution represents that if output is same, which means that if fx1 is equals to fx2, then input has to be same. X1 is equals to x2. If this if this was the only case of this solution, then we would have said the given function is 1, 1. But right now, we also have second solution, which says that the output would be same, which is fx1 is equals to fx2, if the two values are opposite in signs. The magnitude is same, but the opposite in sign. And you can also check that. Let's say you put x2 as 2, then x1 is minus 2. And 2 and minus 2 both can be given to this function because the domain of this function is integers. So you can put any integer. So because we are having two solutions here, I mean, for this case, we have two solutions. So we can say that the given function is many one. Now let's consider one more question. Yes, Austin, that is where I'm coming at. So let's say the same question is, in that case, the definition, I mean, in that case, the output, the final conclusion will change. How? We will understand that too. Let's consider the same function, but with different domain and codomain. Or let's say codomain is still natural number. Well, I mean, codomain is still your integers, but the domain is now only natural numbers. The domain has changed. In the first case, domain was any integer, while in the second case, the domain is all only natural numbers. So in first case, we could have put 2 as well as -2, but in the second case, we are only putting, or we are only giving the natural numbers as input. The function is same, but the domain has changed, right? In the first case, the function was many one. Now let's come to the second case. The solution will be same up to this point because the expression is same. Everything is same. The only thing changed is that now x1 and x2 both belongs to natural numbers. I told you that you have to take two values, x1 and x2, from the domain. In the first case, the domain was integers, while in the second case, the domain is natural numbers. Now, what does change now? What has changed now? It will provide you the same answer. After solving, you will get, because we have already solved it in the first part. So after solving, I will get two solutions. X1 is equals to plus x2 and x1 is equals to minus x2. Let's write them differently. So the first solution is x1 is equals to x2. And the second solution is x1 is equals to minus x2. So the definition says that now it should have many one solution. I mean, the function should be many one because we have two solutions. But you have to stop here. Why? You have to think that whether these two solutions are valid or not valid. In the first case, both of the solutions were valid. Why? Because you put any x2, okay, so this will always be valid. First of all, this will always be valid. You don't have to check. You don't have to check anything for this. But for the second part, or whatever the solution, you may have three solutions. I'm not saying you will have two solutions only. So, Austin, just give me a minute. इस equation को solve करने के बाद, there can be many solutions. If there is only one solution valid, which is x1 is equals to x2, then we will say the given function is 1, 1. And if there are more than one solutions valid, then we will say the given function is many one. Okay. So in this case, in the first case, you can, how do you check that? You give some value to x2. So let's say you give x2 as 2. Then the x1 is -2. Now you will check whether -2 is coming in the domain. In the first case, it was in the domain because the domain was all integers. But in the second case, if you give x2 as 2, then x1 is coming out -2. Right? X1 is -2 in this case. Just a minute. Yeah. So x2 is -2 in this case, which is not possible if you consider. X1 cannot be -2. Why? Because the set of domain is natural number in this case. यार सबसे पहले तो हमें ये चेक करना पड़ेगा जब आपके पास सॉल्यूशन आ जाएंगे कि एक सॉल्यूशन है या ज्यादा है। अगर एक ही है तो वो होना चाहिए x1 इक्वल्स टू x2। अगर ऐसा है that you have only one solution which is x1 equals to x2, don't think, you don't have to think anything then. The given function is 1 1. But if you have more than one solution, then first you will check whether the given solutions are valid or not valid. First case में x1 is equals to minus x2 होना possible था, क्योंकि अगर आप x2 को कोई भी वैल्यू देते हो तो x1 उसका नेगेटिव टाइम्स होगा, which is perfectly valid. So in the first case, x1 is equals to minus x2 was possible. It was possible. Why possible? Because in that case also, both the values belongs to z. But in the second case, if you put x2 as 2, then x1 is minus 2, which is not valid. Why? Because minus 2 is not a natural number. So in this case, this solution is not valid. And why not valid? Because it does not satisfy your initial condition. Initial condition says कि आपकी दोनों values x1 and x2 should belong to the domain. So it matters a lot whether the given solution is valid or not valid. And how do you check that? From the condition of domain. What was your domain? Okay, let's check some more questions. You solve this one, whether the given function is 1 1 or many 1. Just give me a minute. Okay, can you check this? If R to R, now R is a set of real number. Real number माने minus infinity to plus infinity anything. For the same thing. Don't solve. You already have the solution. Just think whether both of the solutions will be valid for this domain or not. You already have the solution, no? Just think about the part that whether the both solutions x1 is equals to x2 and x1 is equals to minus x2 will be valid or not valid. So take 2x1 and x2 which belongs to real numbers. After solving, you will get two answers. x1 is equals to x2 and x1 is equals to minus x2. First, I want to hear your opinion. Then I'll discuss this. You have 30 minutes to, 30 seconds to answer this. Hanji, start. Anyone can give the answer. It's okay. You will be. I'm not expecting the right answer. Okay, how do you check? You don't need to check for this one, first of all. Now come to this. Give a value to x2. What can you put in place of x2? Any real number. Real number is minus infinity to plus infinity. Okay, let's take 2. If you take 2, take x2 as 2 or whatever you want to have. Let's take x2 as 100. Then what is the value of x1 according to this second condition? If x2 is 100, then x1 is minus 100. Does 100 belong to real number? Yes. Is minus 100 belongs to real number? Yes. So take any one value, कोई भी एक वैल्यू लो, पुट करो, देखो दूसरी जो वैल्यू आ रही है x1 की, क्या वो भी रियल नंबर को बिलोंग करती है? So take any value for x2, right? And check whether the given x1, for the given x2, whether the x1 which we get belongs to the domain or not. If x1 also belong to the domain, then the given function is many one, because both of the solutions are true. Possible. This solution is valid in this case. Why valid? Because x1 and x2 both will be real number. If you put x2 some real number, then x1 will also be a real number, because minus does not change anything. Hence the given function is many one. Please feel free to ask your doubts, because there is no problem. If I have to tell it again, I have no problem. In most of the cases, your domain will be all real numbers. But these questions were for your understanding कि ऐसा हमेशा नहीं होगा कि यार दो सॉल्यूशन आ गए तो भाई अब many one है, नहीं. हो सकता है 2, 3, 4 सॉल्यूशंस आ रहे हो, बट वो वैलिड ही ना हो. वैलिड सिर्फ एक ही हो, x1 is equals to x2. So check for the validity of all the solutions other than x1 is equals to x2. Okay, check for this. Y is equals to 2x plus 7. Check for y is equals to 2x plus 7. Ted, it's correct. Good. Correct, Austin. इसको सॉल्व करो, fx1 is equals to fx2. ना पहली बात तो fx क्या है? यही है यार y. You can replace y with fx. So you can also write this as fx is equals to 2x plus 7. y लिखा हो fx लिखा हो एक ही बात है. अब आप fx1 is equals to fx2 बोल रहे हैं, तो इसका क्या मतलब हुआ? 2x1 plus 7 is equals to 2x2 plus 7. ये तो कैंसिल ही हो जाएगा, दोनों साइड है. बचा क्या? 2x1 is equals to 2x2. क्या आंसर आया? सिर्फ एक ही आंसर आया. 2 से 2 भी कैंसिल हो जाएगा, तो आंसर आया सिर्फ एक, x1 is equals to x2. As there is only one answer present, hence you can say that the given function is 1, 1. Tharif, Humamuddin, Faiza, guys, please feel free to ask whenever you, if you are not able to solve it, then ask me. Okay, so here the function is given from z to z, one integers to integers, and the function is fx is equals to x cube. Anji, is someone able to solve the first question? What is the equation first? Let's go one by one. Let's go one by from one through one by one step. So what is the equation first of all? fx1 is equals to fx2 now. Anyone can tell me? Shahid, you're correct. Good. Shahid, solve this one. It's given in your NCRT. The question number 9, page number 11, question number 9. Okay, so the equation would be what? fx1 is x1 cube. You just put x1 in place of x in this. And this would be x2 cube. Right? Now, right? And we have a formula for a cube minus b cube. This is some similar to a cube minus b cube, which is a minus b a square plus b square plus ab. So this, we can use the formula. This is the formula a cube minus b cube, which gives us basically a minus b a square plus b square plus ab. Now, the first equation gives you x1 is equals to x2. This equation, right? If you put x1 minus x2 is equals to 0, then you will get x1 is equals to x2. From the second equation, this does not have any solution. This does not have any solution. Okay, you can write it like this, right? And the first three things is a formula for x1 plus x2 whole square, x1 plus x2 whole square, right? And this minus x1, x2 can be taken to the right hand side, plus x1, x2. Now, if let's say x1 is negative and x2 is positive, this is not possible. There's no solution to this equation. And how did we identify that? Because see, if x1 is positive and x2 is negative, so if x1 and x2 both have opposite signs, then there is no solution of this equation, right? And if x1 and x2 both are same, sorry, both have same sign, then also we don't have any solution for this equation. I can prove that. How can we prove that? Okay, so let's solve this equation. We can say that no solution. So only one solution is valid for this case. Only this solution. We don't have any solution for the given equation, for the second equation. So because there is no solution to second equation, that is why the given function is 1, 1. But we can prove why there is no solution to this equation. Yes, we can. Yes, we can. But Austin, the cube root doesn't work like that. I mean, square root also doesn't work like that. There are multiple solutions of a cube root. So to find out the roots, this is always better to factorize. I mean, without factorization, your roots may be wrong. Now, why? I mean, this is competition. You would have studied complex number in class 11th. So I don't know someone told you or not, but square root and cube root doesn't work like simply we can take square root. There are also other components in that. So it is always better to factorize rather than taking roots. Okay. Yes. Okay, divide the whole equation by x2 square. If we divide the whole equation by x2 square, then this equation changes to this. Now put x1 by x2 as some other component t. Now let's put x1 upon x2 as t. Then the given equation is t square. This is t square, x1 by x2 whole square. This is t plus 1. And you find out discriminant for this. We used to find out discriminant b square minus 4ac, whether a given equation has solution or not. So d for this equation will be b square, which is 1 minus 4. There is no real root for this given equation. No real root. Hence, no solution. Of the equation. So we can say that the given function is 1, 1. Why? Because we had two solutions, but one was not valid. Similarly, you can solve out 6th also. But I think you have class from 9, right? Who has class starting from 9? Raise your hand. Okay, there is no class scheduled at 9. Okay. Okay. Then we'll continue this in tomorrow's class. Cool. Okay. Practice this question, 6th one, and we will continue more questions on 1, 1 and many 1, as well as into and onto in the next class. I mean tomorrow. And after tomorrow, we will have an extra class in the coming week. We will shortly notice you the timings of that class. Chalo, try this one, and we'll meet tomorrow at the given time only. I mean 6:30. Sorry guys, for today I had a meeting which I can't avoid with my professor. And please look all these questions which we have solved today in the class. And please feel free to come with me with your doubts. If you have